Welcome to a new episode in my Weidmüller automation controller series. Last time we looked at how the automation controller can communicate with other devices. The examples we have seen allows the automation controller to send data to different devices. But today what I'm going to focus on is how you can store this information on the device itself. And I think this is going to be a very important topic because even if you have an automation controller which is connected to the network and it talks to other devices and it shares data, for security purposes, you might want to also back up the data and store it on the device as well. So in case the network is lost and you can't communicate it, you can always go back, you can look at those files and you can see what happened on the automation controller when it was out of reach for remote access or remote monitoring. If you are new to the Weidmüller automation controller, I covered the basics and what this device is and how it works in my first video, so you can find the link here, or you can also go to the video description and you can find the link to the playlist for this entire series. So I'm going to cover a couple of topics today. First of all is how we can save data into files. So we are going to see how we can simply create files or read files from the automation controller, how we can store files in various formats, for example CSV and JSON, how we can also retrieve that information. And I'm also going to show some tricks. For example, I've created a flow which automatically creates a new CSV file every day. So you just feed the data in and it will automatically generate a new file in the beginning of the day. And because we don't have basic access to the automation controller, for example, we can't open a terminal window, or maybe not as of now, I've also built a small UI when we can look at the files that we have saved on the automation controller. And for example, we can, graph the data of from these various files. And besides what I mentioned just a couple of minutes ago, I think the reason this topic is also important because normally you would install some sort of database server on a device, or let's say if you are running this on a Raspberry Pi, you have full access, you can install additional programs, for example SQLite or other database application, and you can use those databases to save information. On the automation controller we can only use the softwares that are provided by Weidmüller, and at the moment there are no database management software. So pretty much the only option we have in terms of storing data is using files. I mentioned this a couple of times before, even though I didn't show it on camera, but it's possible to put a micro SD card into the automation controller. So this is what we are going to use in this video to store data on. As I mentioned before, because we don't have a terminal access to the automation controller, we can't easily list files or open files from the device. So for that reason, I've created this flow, which is basically a very simple file explorer. And I've done this on the UI. The only special thing that I've used for this one is this file lister node, which you can install from here. So if you go to the palette manager, and it is called node red contrib fs. Actually, I did show the file management in a previous video when we talked about the communication, because we looked at how we can serve a local file in an HTTP endpoint. So I have shown the two nodes, well actually one of the nodes that we can use to store files. One is the file and the other one is the file in. So the file obviously loads a file from the local drive, and the file in is the node that we can write whatever content into a file. And of course I have this fs file lister as well that I've just installed, but by default you are getting these two nodes. So the simplest example is the following. I have an inject node, and in that inject node I haven't done anything. I just put the timestamp in and I said, the data that comes out of this inject node goes into the file node that you can see here. And if I open the properties of this node, we can see that we can specify the file name. So again, I specify the path, which is the SD card path, and just simply created a file which says simpletext.log. I've selected that I want to append this file. Of course, if it doesn't exist, it gets created. And whenever I put something in it, the Node-RED is automatically put a new line character at the end. And that's pretty much it. So if I go to the UI, so this simple text already exists. So let me just delete it for now. As you can see, simple text it's gone now. And if I click, then, well, nothing really happens on the UI. I mean, we can look at the debug, but nothing really happens. The data has been written to the file, and if I refresh, I can see that I have a simple text.log, And if I open this, then we can see that's the timestamp. And if I trigger it a few more times, what we will see that all the additional data gets written into subsequent lines of the file because we have set it up to append. So if I refresh now, we can see it's 14 bytes. If I refresh now, it's 56 bytes. If I download it again, now you can see the couple of timestamps that I've loaded or I put into the file when I clicked on the inject node. So very simple process. Basically, whatever you send into this node in the payload, it gets written into the text file as a text. And of course, if you set it to overwrite, then the existing file gets overwritten. So if you only want to store the last information, you would set it to overwrite and it would just only store the last message. And of course, this process is not restricted to strings only. You can write any binary data into a file. Maybe you just need to play around with the encoding as well. Actually, no, you can leave it on default encoding. And if you send in something which is a byte stream or a buffer, then it gets written into the file as, for example, like an image file or a generic binary file. So that's it. The next example is when we want to put some formatting into the data, what we write into the file. So this example also starts with an inject node. The inject just creates a timestamp and I'm overwriting that data here. So as you can see, into the payload, I'm putting an object. And by the way, up until now, I only used the change node, how I put something into the payload. So now you can see how you can do it in JavaScript as well. So curly brackets to start an object. And this object is going to have three properties: the timestamp, which is going to be the current timestamp, again in number of milliseconds passed since the 1st of January to 1970. And it's also going to have a pressure property, which is going to get the pressure from the global, and the out2, which is again going to get the out2 value from the global. It's exactly the same data that we have used in the previous example. So it's always going to create an object with these three properties. And what I'm going to do with this, as you can see from the output of this node, I have two wires. One goes into the CSV node and the other one goes into the JSON node. The JSON node is the easiest one because all it does, it converts the JavaScript object to a JSON string and back. And it knows that if it receives a JavaScript object, like in our case, that it's going to convert this into a JSON string, and that we can send into a file. So we send it to the json.txt. And this is also set to append. And on the other wire, we have the CSV node. And in the CSV, when we are converting the object to CSV, as you can see, you have one option to say include the column name in the beginning, which I've unchecked now, and just add a new line at the end of the line. And here on the top of the properties, you also specify the columns, and those are basically the attributes in the object that you want to save into a file. And you can specify whether the file is going to be, what's the separator. And of course, I'm leaving it on comma because that's going to be a CSV. And I'm just going to write it into another file, which is the object CSV, and that's again set to append. I have unchecked the add a new line because that gets added by the CSV node already. And if I go back to the UI, what I want to do is delete the existing files. And the other file that I use, the objects.csv, which doesn't exist at the moment. So good. Let's again trigger the inject node. So that's going to create the object, and it's going to write it in two different files, into different format. So if I refresh, first of all, I see a json.txt. And as you can see, basically the string or the JSON format of this object gets written into a file. Very simple. And the other one, the objects.csv, creates a CSV file. And as you can see, I have the three data written into the CSV. And of course, this is comma separated, but I have Microsoft Access set up that it knows that the separator is comma, so it automatically puts into three different columns. It doesn't have column headers. We are going to deal with that later. But this is what we expect. And if I trigger it again, and maybe I trigger it again, then what we will see is, because both of them are set to append, the new data would just get written into a new line. The pressure hasn't really changed, but as you can see, we are definitely getting new data because the timestamp is different. And if I do the same for the CSV file, then I'm going to see the free data that I've created as well. So it's a very simple way to save data into either CSV or JSON format. And in the next example, we are going to see how we can read data also from this file. And one of the reasons I highlighted JSON, because I think it is a very good way to store, for example, system settings into a file. And we have seen in the past how we can use the global or the flow or the node context variables, but always keep in mind that these variables will disappear once the automation controller, for example, loses power or it reboots, because those are, you know, runtime variables. So if you have some settings that you want to save, I think the best example is just to save them into a file, and you can just read them up whenever the automation controller starts up. So in this example, I'm actually using the weather JSON that we have used in the communication example. It doesn't really matter. I just wanted a complex object to test with. So as you can see, it is an object which has attributes, and the attributes themselves are different objects. And this has an array as well. And yeah, even more objects down the line. So this is the object that I have in the inject node. So when I click on this, this object is going to go through here. It goes into the JSON node, it converts it to a text, and we are going to write it into a file. And I set this file to override. So it's, let's say this is our program settings, and let's say that you keep all your program settings in a big object, and you can just easily, you know, dump it into a file whenever these settings are changed. And of course, you want to override the, you know, the previous settings. So now if I click on this one, and if you look at the files, I called it the settings.json, that we can see that everything is written into the file. I mean, I don't have the same visual representation because all the white spaces and the enters are removed, but you can see every information here, and we can just as easily read this information to the file. So I'm just going to use this inject node to trigger the file read. This goes into this file in node, in which I've also specified the same file name. So I want to read this file. I want to read it as just a string, like a text. And then it goes into the JSON, obviously, so it gets converted back to a JavaScript object. And then I just put it into the screen. So for example, if I do that, we can see that we were able to retrieve the information. So we have the object, and the coordinates is another object, and the weather is an array which has one element, which is itself an object, and there are more objects here. Exactly the same data that we have started up here, we will be able to, you know, put it into a file and just as easily read it up. So if I refer back to that settings example, this would be the trigger whenever your settings are changed. You save it into a file, and you have the inject node, and on this inject node, you click this option which says inject or trigger this inject node 0.1 seconds after the Node-RED starts. So whenever Node-RED starts, it's going to trigger this, read the file content, convert it to a JavaScript object, and for example, you can store this into the global context or in the flow context. Up until now, whenever I was writing to a file or creating a new file or reading from a file, I've specified the file name here on the properties of the file in or the file node. But it is also possible to pass this information from a code. So if you have a code which needs to specify what file name to use, you can use that as well. So up here, you can see that I have a weather JSON. It's basically the same as up here. So this contains this weather information. And I have a file node right at the end of the process. And here you can see that I haven't specified a file name. So this file name is going to come through this function node. And if I look at this function node, it looks a little bit complicated, but what really we need to look at is this single line. So if I set a message.filename and then pass this into the file node, then it's going to use whatever file name that I've specified in here instead of, you know, what I specify up here, which is, well, in this case, it's nothing. So going back to the JavaScript code, what I have done here is I take the current date and time from the system, and I just basically start slicing it into the year, the month, the day, the hour, the minute, and the second. And I'm just going to construct a file name, which is going to be like, again, /run/media/mmc/weather, and then it's going to contain the current timestamp and .json. So if I trigger this, then actually you can see I've also printed the file name here, and it also appears here on the file node that the file that is actually got saved is the weather, and then it contains a timestamp. And if I do it again, then of course it's going to be slightly different because a couple of seconds has passed. Well, hopefully a couple of seconds has passed. So if I look at the data that I've created, now you can see that we have created several files where the file name contains a timestamp of the current timestamp. The data in this case is the same because, well, it's coming from the same inject node, which hasn't changed, but at least this gives you a good example how you can programmatically change the file name instead of hard coding it here on the file node. And if I go back to my settings example that I talked about here, you can save the settings into a fixed file, but you can also use this flow to always save a copy of the settings, whenever it got changed. The next example I've created, I just called it autologger. And the point of this file, which you can also see it here, is I want to save data. For example, I'm using the same example that we have used before. So it has a timestamp, it has the pressure, and it has the out2 value. So I want to save that, but I want to create a new file every single day. So I'm logging this data continuously, but the system automatically creates a file every single day. So I don't have one big file, but I have one file for each day. And the flow starts very similar to what we have seen above. So we just have a simple inject node, there's nothing special here. And then we are putting the same object into the payload that we have seen before. So it has a timestamp, a pressure, and the out2 values. And of course, well, the pressure is going to change, but the timestamp is definitely going to change with every single value. And then we are using the same file name generator node, almost the same that we have seen above. And again, this is generating a file name which contains the year, the month, and the day. So I'm storing that in the message.fname. So this only contains the file name. And I've also generating the full message.filename, which contains the path. So /run/media/mmc and the file name. And I'm also saving the actual payload into a different object, the message.fileContent, and I'm replacing the payload into a special object which says pattern, and that pattern attribute contains the current file name. Because what I want to do now is I am passing this file name into this file lister node, which is basically just going to look into the SD card, and it's going to look for that file name. Because this is how I'm going to determine whether that file already exists, so I can append to it, or the file doesn't exist, so I need to create it. And so this file lister node, you can specify it to look into a folder. You can specify the find pattern, which in here on the properties I have specified it as star.star. But if you read the documentation, you can see that by passing a special payload into this node, you can override the options that you specify here. So I generate the file name up front, and I'm giving it to the file lister node to tell me whether that file exists or not. And this file lister node is going to return an array which contains all the files that it has found. And I can count this array, how many elements it has. If it has 0 elements, that means that no files found with the exact same file name. So the file doesn't exist, it needs to be created. So then the data goes out to port 1, and otherwise it goes out to port 2. So port 1, that's when the file doesn't exist. And what I'm doing in this change node, I'm retrieving the data, the object that I set here. So in this function node, we have seen that I put it into the message.fileContent, and now I'm putting it back to the payload. So at the end of this change node, the payload contains the data that I want to save. It goes into the CSV node. in which I specify the columns, so the 3 fields that I want to save. And in here I have specified that I want to include the column name now. This is the time when we create a file, and in this new file we want to create our first data, but we also want to create the column headers. So it's a nice, proper CSV file with columns as well. And then I write it to a file. And again, because up here we have specified what is the file name, this file node knows what file to write to. As you can see, logging 2020-08-14, and that's today's date. And if this switch node returns anything other than 0, which, theoretically it should only be 1, so the file exists, then it goes to the same change node, which does exactly the same as in the previous example, and it goes into the CSV node, which is almost exactly the same as the CSV node above. The only difference is that it does not include the column header now, because we already have the file, it already has the column headers, so any subsequent data should just save the data itself without the column headers. And the other thing I wanted to stress here with this example, which I don't think I have explained in any of the previous videos. By convention, every single node is designed to change the message.payload, but then leave the rest of the message object intact. So if I want, for example, here to send an information past for example, the file lister, which I know is going to change the message.payload, this is why I'm saving data into the message object, because full message object will always get passed from one node to another. It's only the payload changes. So if I set the message.filename here, that's not the payload, that's an attribute of the message object itself. So this file lister node will not touch that. So this is why the file name that I specified here will get passed through this, and will get used here. And similarly, I'm saving the payload at this point into the message.file content, and that information passes through the file lister, the switch node, and in this change node I can use that to put it back into the payload. So I think this is an important principle about how this node works that you need to understand, because in most cases you will need to use this. So of course you could save this information into the flow, but you really shouldn't be doing that, because that flow variable might get overwritten if this flow gets triggered multiple times before it reaches the end. In that case you will definitely lose data. So the best is to save data into the message object itself, because that will not get changed by the subsequent nodes. And just to prove that this code works, I've actually created this flow a couple of days ago, so we have 3 files created as well. I think I've done it like a day before yesterday evening, so the first file is actually quite short. But if I look at it, we can see that yes, it has the timestamps, and it has the various pressure and the out2 values. And if I look at one of the other files, which contains the full day worth of data, then we see that we have a lot more data. And we only have the column header once on the first row, and then everything else is just data, as you would expect in a normal CSV file. And by the way, the reason this is creating all this data, because up here I've created this inject node, which basically fires every 10 minutes. So new data gets saved into the file every 10 minutes. And before we go to the last example, I just want to show you how the file browser works as well. So it basically revolves around this file lister node, which I've set to look into the MMC folder. So that's the folder for the SD card, and it looks for all files, and it only looks for the files, so it doesn't look for folders, and it's going to output the values into a single message object. And if I look at the debug, because I think I've already, oh no, the debug is not enabled. So let me enable the debug and then manually trigger this. Then you can see that because I have 14 files, I'm getting an array with 14 elements. And if I look into any elements, then we can see that we get the file name, and then we get a stat object in which we are also getting the size and then some of the date information when this file was created. So the information that comes out from this file lister node, first of all, it goes into a formatting node, which reformats this array and then puts the file names into a dropdown. So here I select which file I want to work with. And this is why you are also seeing the files in the dropdown. You see them with a full path, but anyway, this is how I did it. So you can select the file. When you select the file, then it gets saved in a flow variable. So we can see that we have saved that file. Yep, that's the file that we have, well, sorry, that's the file that we have selected, because this is the only way for me to store, okay, that I've selected this file, and when I click on the delete button, that I should be able to know what file I want to delete. So when I click on the delete button, for example, so this is the delete button, it has the icon delete, label delete, nothing else. And then when I click it, the message comes out and it goes into the function node. And in this function node, I'm checking what is the flow variable that we have created. If the flow variable is undefined, which means it doesn't exist, then we just return it and we don't do anything. Otherwise, we put the file name into the message.filename. So this is the file name, how we inject into the file node, which comes next. And I've also delete this flow variable, because what we are going to do next is we are going to delete the file. So we shouldn't store that file name into the context anymore, because it would just get deleted. And then this information passes into the file node, and this time I set the file node to delete it. So it gets the file name from the message.filename and it's just going to delete it. And then once it deletes it, I send the trigger back to the file lister node, so it updates the screen. And this is why if I select this JSON and I delete, you see that the screen refreshes and the file disappears from here. The next thing that I'm doing, which is actually responsible for displaying this list, and we are going to see some nodes that we haven't used before. First, the data goes into the function node, and in this function node, I'm just doing very simple stuff. I am reformatting the created, the change, the access, so the 4 dates into a string which we can easily display on the screen, because otherwise by default it gets formatted to a very long string. So I'm using some JavaScript commands to convert the date into an ISO string. And what I'm also doing is I am slicing the path off from the file name. So I don't see the /run/media/mmc something in the beginning of the file. So this is how you can easily do that with one single command in JavaScript. And then this modified information goes into the template node, which we haven't used before. And with this template node, you can format your data into an HTML table. And if you know HTML, you can pretty much understand what's going on here. So I'm creating a table, and this table has a couple of columns. And in the column header, I'm setting file name, size, created, changed. In the actual rows, I'm creating also all the contents. And as you can see with this command, the hash payload and the /payload, I can loop the code which is inside here per payload elements. So this assumes that this payload it contains an array. And if we remember the output of the, let me just go back here. Yes, so the output of the FS node contains an array. So it's going to create an HTML row for every single file that I've created. And it's going to create 4 columns, obviously with the file name, the size, and the created. And it's also going to format the first column into a hyperlink. And this hyperlink is actually going to call this HTTP in. Again, this is something that we have already looked at in the communication, how you create an HTTP in node, how you are going to read the file name. And then I'm going to load this file from using a file node. I load it into a single buffer object, and I'm setting the HTTP header types, and then I just return it to the browser. So we have seen how it works. I just click on it, and then the file gets downloaded, and it actually works for every single file object. And you can just view it with the default viewer. So that's the file browser in a nutshell. And if we come back to the latest example, is how we can graph the data. So I've created a new node which says graph. So you can see it here. You select the file, for example, the first logging, and it's going to get the file name again from the context, and it's going to load the file. Again, the file name comes from the message.filename, and I know that this is a CSV file. It's going to convert the CSV into an object, and I've specified that I want the output to be a single array. So at the end of the node, I'm going to get an array which contains basically the data that I have saved into the CSV file. So if let me just delete the log. So if I want to graph this file, well, we can see it's already updated here, but what we also see here is we see the data, and you can see the different objects which has the timestamp, the pressure, the out2, and they are all in a single array. So everything that we have saved in a file, it now comes through an array, and every single array element is the object itself. I'm reformatting this data into the format that the chart expects. I'm creating a chart object which is actually an array, and it has one element which is an object, and it has a series attribute where I store the series. It has a data attribute which I'm dynamically populating here, and then I'm not using the labels attribute, but I could put a label as well, which becomes the chart title. I'm populating the chart where the X is the timestamp, and the Y, that's obviously the value, the pressure value. And again, for the out2, the X is the timestamp. And this is why I'm storing the timestamp in this JavaScript format, because that's how the chart expects it as well. So it automatically converts it to like, hour, minutes, and seconds date format. And in case of the out2, it contains values as zeros or ones. And I'm just multiplying it by 200 because the dashboard chart doesn't have a second axis. And if I would use zeros and ones, it would be so little we would hardly be able to notice on the chart. And then the entire data gets passed to the chart, which is just a simple line chart. I haven't really specified anything else here. And as we can see, it gets displayed. So we can see all the data. So this is one good example how you can prepare an entire set of data and then pass it into a chart. So it displays, for example, a historic data. So this is just a couple of samples, but if we select another file, this is from, I think, yesterday, so that's probably like a full day's worth of data. And if you look at the third one, I actually paid some attention to click the switches, so you can see the out2 goes to 200, which is 1, goes back to 0, and then 1 and 0 again. So yeah, that's the pressure data, and that's, when the pump goes on and off. Just like for the previous videos, the example that I've shown in this video is going to be downloadable, and you will find the link in the video description. If you have any questions, please ask them in the comment section below, and I will try my best to answer all your questions. But that's all for today. Thanks for watching, and hopefully see you in the next video.